I think people have been talking about it and thinking about it for a long, long time. I mean, that decade of the 60s was very inspirational for a lot of people. You had Yuri Gagarin going into space for the first time, first man, 61. Kennedy stood up in the same year and said they were going to put 2 people on the moon by 69, and it happened. It was an extraordinary decade of innovation and pace of change. And I think a lot of people watched that and were inspired by it and thought, God, we'd like to go there. They heard what the astronauts said when they came back about the magic of being in space and looking back at the Earth. But putting people in space is hard, and but I think that Richard Branson and Virgin like to do hard things. Where we see that there is a demand and it's not being satisfied, we often like to have a look and see whether we could do it or whether we could do it better. And so that's why we got involved. And I think that, in the early days, it became very clear to us that, that actually the thing that was going to hold us back was the fact that the technology that was used to put things and people into space really had not changed over 50 years. And it was very dangerous, relatively speaking, very dangerous. It was very dirty, it was very expensive. And that if we were going to be able to unlock space to ordinary people, we really needed to transform that. So we needed to find new technology, and we waited until we had found that new technology before we started the company. Well, I think it really just reiterated the fact that, although that vehicle is a pretty amazing, it's a pretty amazing piece of machinery and a piece of kit, that, that the safety record of government space vehicles generally is just not good enough. And so that we, as I say, we needed to find something that was different by design, which would appear to give the potential of offering, very, very much higher safety rates from day one. So, I think that theoretically or statistically speaking, the chances of surviving, a trip to space either on the Soyuz or on the space shuttle are about 1 in 50. It's not a particularly large sample size, but nevertheless, that's something which is really not compatible with any sort of commercial venture. Yeah. So, I think that, as I say, we waited until we found some technology that we thought was radically different, and that came in 2004 with the world's first privately built spaceship, Spaceship One. And Spaceship One did a remarkable thing. It flew a man to space 3 times in the same vehicle in a very short period of time. It had no government assistance to do that. And it did it in a very different way. So the first thing it did was, rather than launch a big rocket from the ground, which is very expensive, very fuel inefficient and very dangerous, it actually took a light carbon composite space plane up to 50,000 feet, hung underneath an aircraft and released that spaceship from the air. And we liked that, because it immediately took away all the dangers associated with launch that we've seen in those rockets that are launched from the ground. So that was fantastic. It was also built out of carbon composite, which means that it's light, it's heat resistant, it's very, very strong, and therefore safe, and we like that as well. It had a rocket motor. The spaceship had a rocket motor that appeared to be, very benign, very adequate for the job, very controllable, and again added to the safety case. And then it had this remarkable complete innovation of the way that it came back into the Earth's atmosphere by rotating the wings through 90 degrees in space, so that it comes back into the Earth's atmosphere without any heat build up to talk of. It doesn't need a sophisticated flight control system. It doesn't need the pilots to fly back into space. It does it all by the laws of physics and aerodynamics, and we love that as well. So, taking those 4 or 5 innovations, the carbon composite, the air launch, the hybrid rocket motor, and the feathering wings for the re-entry, we decided that there was a system here that was so fundamentally different in design, and the design was so fundamentally better, that we should go for it. That we should take that technology and see whether we could commercialize it, and that's what we did in 2004. And in 2011, 6 years later, we're very close to offering the commercial service. There is a great hope for ordinary people to go to space, whatever that means. But but let me answer your question. We have I think about 410 people now from 45 countries around the world, including India, who decided to become a pioneer in this new industry. And they are very important people to us, because I would not have a job today, we wouldn't be talking, we wouldn't have a spaceship if we hadn't found that first market, and these people from around the world hadn't been willing to step up to the plate early to say that we want to back this, we want to help it happen, here's our money, in exchange for an early seat. So that community of our future astronauts has done, us and I think the world a tremendous service by being willing to do that very, very early. The ticket price that we set right at the beginning was $200,000 US. We're spending a lot of money on this project, maybe $400 million by the time we finish. And so we have to have a commercially realistic price to start, and $200,000 is that commercially realistic price. However, the good thing about this spaceship is that it's relatively inexpensive to run. So it means that we should be able to make the price of the flight progressively more affordable over time. And so I think, to answer your question, we hope that we will be able to embrace more and more people in time as that price comes down, and to offer, maybe tens of thousands of people eventually the chance to experience the magic of space for themselves. In the first year of operation, we aim to fly 500 people, and that is a little more than have flown to space in the last 50 years. So this is very different. They'll get an experience that they will never ever forget. And that, I think, is the lovely thing about selling this experience. I suppose is that it's very hard to think of anything else that you can pretty much guarantee that people will talk about for the rest of their lives. And so the ride itself, it actually starts. It starts the moment they book a ticket, but of course the real experience starts 2 days before the flight. They're going to have 2 days with their crew and their pilots in Spaceport America in New Mexico in that fantastic setting, learning about the space flight, learning about the safety procedures, simulating as much as possible of the space flight, because this is a very intense experience. It's sensory overload from start to finish, and the more that we can get people ready for that, the more they're going to enjoy it. And it's very important this is an enjoyable experience as well as a safe one. So you'll accelerate, for example, very fast, going straight upwards away from the Earth's surface. You'll accelerate up to over 3.5 times the speed of sound. You'll have G-forces on your body of about 3.5 Gs. That is going to be exciting. There's going to be noise, there's vibration, the sky outside the window is going to be changing colour, you're going to be pressed back on your seat. It's going to be very intense. And then suddenly, when the rocket motor cuts out, you're in a completely different environment. It's complete silence. You weigh nothing. You'll be able to leave your seat and float around in the cabin in zero gravity. And then what I think will be the real moment for most people is drifting across to a window, floating across to one of the big windows in the spaceship, and looking down on that fabulous, fabulous view of the Earth beneath you from the blackness of space. You'll see the curvature of the Earth, the thin blue line of the atmosphere. You'll see the coastlines, the oceans, the clouds. And we know from what professional astronauts have told us that changes you. It changes the way that you regard, the place that we call home, and maybe the nature of life to some extent as well. So I think, there is no other experience on Earth, almost by definition, that can match that, because this experience isn't on Earth. It's away from it. Those people that sign up first are having a great time already, because they're very involved in the project as we progress. But they will, they'll come back. For some of them, they'll be the first astronauts that their country has ever produced. So it's a very exciting proposition. We'll be taking people up to about 110, 120 kilometers above the Earth's surface. In order to get your astronaut wings, and we need everybody to have astronaut wings, you need to get to at least 100 kilometers above the Earth. So that's the Kármán line. It's where officially, the atmosphere ends and space starts. Although, when you're up there, it looks like the atmosphere actually ends a long way beneath that. But anyway, so 100 kilometers plus for astronaut wings, and the total journey time is about 2 hours from start to finish. So this is a suborbital flight. It's a blast into space and back. It's the first stage of manned space flight, really. And one of the things that we have to prove is that we can take this first step safely and run a commercially successful business from it. And if we can do that, then we'll be able to go on to more, and bigger and better things in the future. So it's a step at a time. But this suborbital flight that we're offering at the moment will give people, the complete astronaut experience, but without having to devote your life to it. You don't need special experience. You don't need to have to speak Russian. You don't need to take, a year off work. You can come, have the experience with maybe a week off, a week's holiday. Yeah, we have our medical team. We have a chief medical officer, an expert in space medicine, and again, the suborbital flight, because of the time that you're in space, doesn't present some of the health challenges that a much longer space flight would give. So which is an advantage, means more people can do it. You do get some G-forces which don't last for that long, but are things that we need to make sure people are able to cope with. One of the interesting things when we started the business was there was no real data anywhere in the world to say who could do that. Because most people that pull Gs are professional pilots or they're professional astronauts. And so we used a human centrifuge, a machine which simulates or produces G-forces, and we took the first 100 people who signed up for Virgin Galactic, and we put them through the human centrifuge, and they experienced G-forces, or the G-force profile that they'll experience on the space flight. And out of those 100 people, there are only 2 that we weren't able to put on the centrifuge, and we had people from age 18 to 89 who did it, and a lot of people in their 60s and 70s, a lot of the complete range of health histories. And we were very encouraged by that. So I think it's true to say that there will be some limited medical conditions which mean it will just not be safe to fly. But if you're generally healthy, you're generally well, then you should be fine. So we of course will make sure that that's the case before you fly, because we want to fly everybody safely. Yeah, I mean those are the things really. And as I say, you don't need formal training, because you could in theory turn up, get on the spaceship, sign the forms, make sure you understand the safety procedures, get on the spaceship and fly. But if you're going to really enjoy the experience, we feel it's much better, to have as much simulation as possible of those 2 things you mentioned. So, and we can actually do that, or we plan to do it in the carrier aircraft. The aircraft that takes the spaceship up to space can also pull G-forces. The cabin of the aircraft will also be the same as the cabin of the spaceship. So when you're with us for that couple of days before your space flight, some of that time will be spent in the aircraft cabin, getting used to what high Gs and 0 G feels like. And there's certainly ways of coping with that experience in a way which makes it much more enjoyable. Yeah, I mean, I should preface this by saying that what we're focusing on at the moment is making sure that our space tourism business starts as soon as possible and start safely, and we'll be flying out of New Mexico, and that's what we're really looking at the moment. But we are aware that if we do that job well, there could be other things on the horizon. So to give an example of that, which may or may not happen, is that we could, for example, see a good market for science research. There are scientists around the world that want access to the upper atmosphere. They want access to microgravity for all sorts of science reasons, research reasons. They want to test equipment in space. And at the moment, it's very expensive and it's very hard to get that access. So I think that we can offer the scientific community a fantastic platform, which we hope will really further some of the most important areas of science that we're dealing with at the moment. I think it could be possible for our basic system to evolve and be adapted to carry small satellites and put those into orbit rather than putting passengers into space. And again, the small satellite market is a market where you see the satellites getting smaller and lighter and smarter, but they're still being put into space by the same rockets that have always taken them there, which are pretty expensive and the supply is quite limited. So I think we could offer an amazing service, if you like, to both those areas. And I think if we were to look much further into the future, and this is real crystal ball gazing, I know something Richard Branson would love to do, would be able to fly people, from one continent to another vast space, which would be a lot quicker and a lot cleaner potentially. But that's some way off. What we have to do is to make sure that we can demonstrate that we can take people to space on a daily basis, keep them safe, make money from it, be commercially successful. And if we can do that, I think you could expect to see innovation in this sector happening pretty rapidly.